Chapter 2, Measurement and Problem Solving. Chapter 1 was nice. This is really important stuff. So stay with me here. I skipped section 2.1. I don't remember, but I'm pretty sure I had a good reason. So read through it, but I think that's one of those fluffy sections. So, scientific notation. Have you guys used scientific notation before? Okay. Scientific notation is just a way of taking really big numbers or really small numbers and making them easier to read by using factors of 10. So when we write a number in scientific notation, there are two parts. There's a decimal part. That's this part at the beginning, before the times. And then times 10 to 10 raised to some power. So the decimal part is going to be 1 or greater, but less than 10. So it's going to be one non-zero digit, and then it may have a decimal point and some other stuff. So it could be 9, it could be 8.4372, it could be 1, but it can't be 0.9 or 10.7, okay? The exponent here is always going to be a whole number. If it's a positive exponent, it means that the 10 is multiplied by itself that many times. So 10 to the 0 is 10 multiplied by itself 0 times. Like, how does that work? Well, we'll skip that one because that one doesn't make much sense. 10 to the first power. 10 multiplied by itself 10 times, one time. So, I'm sorry, it's 1. 1 multiplied by 10. 1 multiplied by 10, one time, so that's 10. 10 squared is 10 times 10. 10 cubed is 10 times 10 times 10. The way I prefer to think of it is this way. Let's see, yellow's not going to work. Let's go with purple for fun. This is the number of zeros. 10 to the 0 is a 1 with 0 zeros. 10 to the 2 is a 1. Gosh, how did I do that? I do some crazy things by accident. 10 to the 2 is a 1 with 2 zeros. Okay? So this is where things really start building. And so the time to ask questions is at the first part that you don't get. And the thing about asking questions is, if you have a question about something, there's probably 3 or 4 other students in the class that have the same question, but they're not willing to ask it. Okay? So they'll all secretly cheer if you ask the question. So do your fellow students a favor and ask questions. If the exponent is negative, so 10 to the negative means that it's 1 over. So 10 to the minus 1 is 1 over 10 to the 1. So that equals 1 over 10 to the first power. This is equal to 1 over 10 squared. I don't know why I do that. I say one thing and write something else. Everybody with me? So what we're doing when we write a number in scientific notation, basically we're factoring out powers of 10. So there's 2 ways, at least 2 ways to think about this. This is one way. Okay, we take this number, 5,983, and it would have a decimal point right here, even though there isn't actually a decimal point there. We need to move that decimal point over so that it's after the first non-zero digit. This is the less math way of explaining it. So I'm going to put the decimal point after the 5. Then I need to figure out how many places did I shift the decimal. That's what these little lines are. 1, 2, 3. I moved it 3 places. That means the exponent is 3. So this is 5.983 times 10 to the third. Then the problem is, Is that a positive exponent or a negative exponent? And this is one area where I do it a little different than your book. The way I remember it is I look at this number. 5,983, is that a big number or a small number? That's a big number. If you think about that many cantaloupes, it's a lot of cantaloupes, right? 5,000, big number. Big number, positive exponent. Big paycheck, positive feelings, okay? Right? So this number, 0.00034, we're going to move the decimal point from where it was to just after the 3. We need one non-zero digit, decimal point, and then anything else that might be there. So we count with our little loopies here. We moved it 4 places. That means the exponent is 4. Then we have to decide, plus or minus. This original number, big number, small number? Small number. Small paycheck, negative feelings. The exponent's negative. Okay? Now, the more math thinking way, if I take this and I factor out a 10, if I divide by 10, then I've got 598.3. Well, actually, let's not do that. Let's just say that is equal to this times 10, right? And it's also equal to 59.83 times 10 times 10, right? I just divided by 10. I pulled a 10 out of that number. And I can pull out one more, and I've got 10 times 10 times 10. 10 times 10 times 10 is 10 to the third power. So that is 5.983 times 10 to the third power. Yeah, I'm going to have to watch out for that, or adjust the screen. There it is. That's all scientific notation is, factoring out powers of 10. The large ones with the positive exponents are easier to understand in this fashion. You can do the same thing over here, but I'm not going to because it'll be kind of confusing. Any questions? So we need to know how to take a decimal notation number and put it in scientific notation. So, examples. The total U.S. national debt in 2010 was approximately, what is even the name of that number, right? You have to kind of think about it. And these zeros, it helps with the commas here, but there's lots of zeros there, right? So anyway, there's the number. Express it in scientific notation. We're going to put the decimal point after the first non-zero digit. So this is dollars. And for, yeah, keep pushing the wrong button. So the dollar sign is the unit that comes first. 1, and we put the decimal point there. And then we write down these other non-zero digits, 2, 1, 0, 2. We'll learn what to do with those zeros later. For now, we're just going to ignore them. So that's our decimal part times 10. And then how many places did we move that? Well, 3, 6, 9, 12, 13. Right? 13 places. That means the exponent is 13. Is that a big number? Yeah, it's a huge number. Positive exponent. So that's the number in scientific notation.
So how do you know, like, how you count the 1.2102? How do you know to keep the rest of them just because there's numbers?
You would, for now, just go until you get to the last non-zero digit. And if the rest of it's all zeros, you can just drop those for now. Significant figures is a concept that's going to help us know which of those zeros we need and which ones we don't. Well, we haven't learned about that yet.
So normally, would you keep like the 1.2 times 10 to the 13?
No, normally I would keep all of it. 1.2102, yeah. Other questions? Yes?
The period after the first non-zero number is for both of them, whether it be negative or positive.
Yep, the decimal point goes after the first non-zero digit. So this bottom one, express the number 0.000038 in scientific notation. So we're going to put the decimal after the 3. That's the first non-zero digit. And then there's an 8 after that. So we'll write that down. Times 10 to the. So 1, 2, 3, 4, 5. The exponent is 5. Positive or negative? Negative. Big number, positive exponent, small number, negative exponent. Okay? Questions? I just want to do another example because we should learn how to go the other way as well. So what if we have a number like 7.405 times 10 to the 6? And we want to put that in decimal notation. What do? Well, this 6 tells us that we need to move that decimal point 6 places. Positive 6 means this is a big number, so I'm going to move the decimal point to the right to make that a big number. So I'm going to go 1, 2, 3, and this is getting all messy. So what I'm going to do is I'm going to go like this. So I'm starting here, 1, 2, 3, 4, 5, 6. That's where my decimal point should be. So then I'm going to fill zeros in to hold the place. And that number is equal to 7,405,000. What about a negative exponent? Well, here's the 1 and the 4. Negative exponent, this is a small number. I need to move the decimal point to the left to make it a small number. So it was here, 1, 2, 3. There's my decimal point, and then I need zeros in there. It's not an omega, it's a 0. Then usually, we will put a 0 before the decimal point to call attention to the decimal point. And then you can always, check it. Okay, 1, 2, 3. Yeah, minus 3. Okay?